So now we will have variance of x1 plus x2 to xn as variance of xi summation plus n minus n into n minus 1 where covariance of xi comma xj. So that one is what? N plus n into n minus 1, that will be 1 into 4. So it will be 4n plus n squared minus n divided by 4. It will be 1 upon 4 n times n minus 3. So n plus 3. So that will be the answer. Now next question we have here is that the joint distribution of continuous random variable x comma y comma z is constant over the region x squared plus y squared is equal to is less than equal to 1 where 0 to z 4. So now this is the region where, let's say, this and then this. So this you can consider as a cylinder, and this is hole is the region. Z is from 0 to 4, and this x1, this is this one. This is the region. X squared plus y squared is not equal to 1. If you see this portion as 2D, this one is the 3D whole plot, whole region. This one is the is just circular part which is given by this. Now the joint distribution is constant. So what is given here is that fx, y, z is equal to constant in this region. Okay, and the region given here is that x squared plus y squared is less than or equal to 1 and 0 to z 4, right? So this is the region given. Now to find this region, what we will do is that one important thing is that if we want to find the integration of this whole region, we can just take integration of this region. We can just find the area of this region and then we can multiply it by 4. Okay. So the two ways to do this integration is that to find C, obviously, limit of x, y, z, f, dz, dy, dx is what? 1. Now z limit is obviously 0 to 4. Y limit is minus 1 by x square to 1 by x square. Sorry. And then x limit will be minus 1 to 4. So basically minus 1 to 1, and this you can write it as Hello everyone, I'm Kamina Mishra from IIT Delhi, and I'm a PhD scholar in statistics, and I'm here as a TA guide in probability statistics. And so the instructor of this course is Professor Sumis Kumar from IIT Kharagpur, and now I'm going to present my screen firstly. Okay, so I think my screen is visible to everyone. Okay. So this is week 7 of this course, Probability and Statistics, and this is a problem solving session. So today we are going to discuss about how to deal with um, distribution, how to deal with the variables, and when we have multiple number of variables. So in the last time we have seen bivariate distribution. So now we will do work with multivariate distribution. So now today we will work with multivariate distribution. So now what happens is that when you have two variables, we all know what happens is that we have let's say two variables x and y. Now if these two variables have certain kind of property that these are independent variables. These are independent variables. And what happens is that we write fx y is equal to fx xx into fy of 1. So this is what? This is joint PDF of x and y. This is marginal PDF of x, and this is marginal PDF of y. Okay, so given here is that x and y are independent variable. So when x and y are independent, then we can write like this. In case x and y follow same kind of distribution with different parameter, then also we can use this. So fx x and fy y will be similar at this point of time, just the parameter will change. I just use some images. Okay. So at this point of time, what we have joint PDF of x and y. We have marginal PDF of x, and this is marginal PDF of y. Now let's just say that we have not just two variables, we have n number of variables, or we have multiple number of variables. So this is what? This is bivariate, right? Now in place of bivariate, if we have multivariate, say x1, x2, x3 up to xn, we have n number of variables, and these all are independent variables. Okay. These all are independent variables. So when these are independent variables, what we know is that f x1 x2 till xn at point x1 x2 till xn will be equal to fx1 at x1, fx2 at x2, and so on, fxn at xn. So this is joint PDF of and variables. Okay, and these are what? These are marginals. These are marginal radius of n variables. But the point here is that these are need to be independent variables. If these are not independent variables, then this will not happen because then there will be some correlation. If so yeah, if it is not independent, then there will be some correlation. Okay, and because of correlation, one more term will come. So now we will move to the questions. So what is given here is that we have given x and y are two continuous random variable with joint PDF. This fxy is equal to k 1 minus x minus y, where x is greater than 0, y is greater than 0, and x plus y greater than or equal to x plus y is equal to 1. So firstly, we need to understand that on which region of R2, because x and y we have two variables. So on which region of R2 this PDF is defined. So firstly, we need to find that. So now we have, let's say, this is given here, right? This is x and y. So this is x, this is y. Now, what is given here is that x greater than 0, y greater than 0. So here x is less than 0, here y is less than 0, here y is less than 0. So this is the only region where x and y both are greater than 0. Now we want to find this line. So this line is that basically if you want to draw any line, just simple use the intercept form. So we can write it as x divided by 1, y divided by 1 is equal to 1, because 1 is there, that's why we have divided by 1. So these are the intercept at 1 and 1. So this is the line. Okay. Now x and y are greater than 0. So this is the region where this PDF is defined. Basically this is 1. And this line is what? X plus y is equal to 1. Okay. Now, so fxy is defined in terms of k, and there is no, there is no, not k is not here in the option. That means k is the constant which we need to find per se. So what we know is that in 0 to in minus infinity to infinity, in minus infinity to infinity, fx y dy dx, if you take the limits of y firstly, is equal to 1, right? Now in place of minus infinity to infinity, we need to take the region where this is defined. So to take the limits of x, we can take the limits of x, which is 0 to 1, right? So we can take firstly 0 to 1, and then for the y limit, the below line is what? This line is y is equal to 0. Sorry, this line is x is equal to 0. So x we will write in terms of 1. So for y, this one is 0, and the upper region is what? This one is x plus y is equal to 1. So y will be equal to 1 minus x. So y will be equal to 1 minus x. Now fxy k 1 minus x minus y, and then firstly we have taken the limits of y, so there will be dy and then dx, and then this will equal to 1. So now we will solve this limit. It will be k will come out, k as a constant, and then for this 1 minus x is constant because we are dealing with a y variable, we are differentiating with y variable, and y is the constant. So for constant, so c dy is what? Cy, simply. So it will be 0 to 1, and the first limit will be 1 minus x, and dy will be y. Now the next one is that just y. So it was minus y. So minus y dy will be y square upon 2. So it will be minus y square upon 2. And the limits are 0 to 1 minus x dx. And this whole is equal to 1. So now it will be 1 minus x, 1 minus x will be 1 minus x whole square, and then 1 minus x whole square divided by 2. In the time of 0 it will be 0, right? So it is basically what? K 0 to 1, 1 minus x square upon 2 dx. Now 1 minus x square we can integrate, and then 1 minus x square will be 1 minus x whole cube divided by 3, and then for because there is minus x, so it will be minus 1, and then it will go from 0 to 1. Now when we will put the limit 1, it will be 0. We will put the limit 0, it will be 1. So it will be basically 1 by 3. Okay. So 1 is equal to k upon 2 into 1 upon 3. So k we will find here is 6. Okay. Now we know this fxy is what? So fxy we can define again as 6 1 minus x minus y. This is 0 else, and this is when x and y both are greater than 0 and x plus y is equal to 1. So this is the variance. Now the question given here is that expectation of x given y is equal to 2. So whenever we have y is equal to 2 given, okay, expectation. So and then sigma square is what? Variance of x1 plus x2, and then since these are what? uh, Independent, these are independent, so variance of x1 plus x2 will be variance of x1 plus variance of x2. So this one is 0.1 square, this one is 0.1 square, that means 0.01, so it will be 0.02, right? So now we know y is what? Y follows n 4 comma point 0. Now the given here is that what is the probability that total thickness exceeds 4.3? So we want to find that total thickness exceed 4.3. So that means we can do just x minus 4 divided by 0.02 greater than 4.3 minus 4 divided by 0.02. So now we can solve this and then it will be probability z greater than or equal to how much? 2.1213, which will be equal to 1 minus probability z less than 2.1213, because we have the z values like this. So sorry if we want to find the probability this greater than, so we can simply do 1 minus this, right? To find z greater than this, we can remove 1 minus this. So that one is uh, so that one we can see 2.1213. We can just go for the z table and then these are for the negatives. So 2.1 is 999778. So this is 1 minus 0.9778, and that one will be equal to 1016. So that will be the answer. Now the next question given here is the fxy, and this is defined in the region. So again, like I have said earlier, but again, firstly we need to find where this one is defined. So x is from 0 to 1, y is from 0 to 1. So this with the region where these lines are not there, this is the region where fxy is defined. So u is given here is that x minus y, and then we want to find the variance of u. So now variance of u will be what? It will be expectation of x minus y square plus expectation of x minus y whole square, right? Because u is what? Variance of x minus. Okay. So this one is expectation of x minus y whole square. This one is expectation. So this is mu. This is second moment. So firstly we need to find x minus y. So expectation of x minus y will be what? 0 to 1, 0 to 1, and then x minus y, and then fxy is x plus y. So dx dy. So this is 0 to 1, 0 to 1. This is x square minus y square dx dy. Let me add some blank pages here. So that one will be what? 0 to 1. So if we integrate with respect to x, firstly it will be x cubed upon 3 minus y square x 0 to 1 dy will remain, will be 0 to 1. X cube 1, so this will be 1 by 3 minus y squared dy. So now it will be 1 by 3 y minus y cube upon 3 0, right? 0 to 1. So that will be 1 by 3 minus 1 by 3. This is equal to 0. So expectation is 0. Now next we want to find expectation of x minus y square. So expectation of x minus y square will be 0 to 1, 0 to 1, and then x minus y square, x plus y dy, sorry, dx dy, and then we can just open it firstly. So that will be x square minus y square times x minus y, which will be x cube minus x square y minus y square x plus y cube dx dy 0 to 1, 0 to 1. So for now firstly we are doing with respect to x, so it will be 0 to 1. For x cube it will be x to the power 4 upon 4, and then 1 will be 1 by 4. X square x cube upon 3, and then y square x square upon 2, and at last y cube x, so y cube x will be 1. Then it will be 1 upon 4 y minus 1 by 3, 1 by y square will be 1 upon 2 minus 1 by 2, 1 by 3 plus 1 upon 4. So it will be 1 by 2 minus 1 by 3, which will be equal to 1 by 6. So now the variance of u will be equal to 1 by 6 minus 0 square, which will be equal to 1 by 6. So 1 by 6 will be the answer. Now we move to the next question, which is given here is that x1, x2 to xn are random variables, such that the variance of each variable are 1, and correlation between each pair of different variables is that. So its variance of xi is equal to 1, and covariance between xi xj given I not equal to j is 1 by 4. Now we want to find the what is the variance of x1 plus x2 up to x. Now what is this? This is variance of xi summation plus 2 summation, sorry, 2 summation, and then I less than j to n covariance of xi comma xj. Now this we want to find. Firstly, what is this? So variance of xi we know. If we want to find the covariance of all the xi, xj. So we need to find the pairs. What are the pairs we have? So for like x1, it will be x1, x2, and then covariance of x1, x3, right? Up to covariance of x1, x0, right? Now, uh, for x2, it will be same covariance of x2 with x1 with x up to just one term will be missing. So this will be n minus 1, this will be n minus 1, this will be n minus 1. So for n terms it is happening. So this total will be what? N into n minus 1. So we will have total n into n minus 1 into the covariance, which is similar for every uh, thing. This one will be xi minus xj, and we have already considered because in the time of x1 we are not taking the covariance of x1 with x1. In the time of x2 we are not taking covariance of x2 comma x2. So these are total covariances, and this is variance of xi. So this is the total variance of summation xi. So now what we can do here is that expectation of x given y is equal to 2. So expectation of x given y is equal to 2 can be written as f of y at 2 and then fx y at 2 uh, x comma 2, sorry, and then it's we will find this function, we will do its integration with respect to x. Okay, this will be the expectation. So firstly we need to find f of y. Now as we have defined that fxy is what, uh, 6 1 minus x minus y, and it is defined in the region of x comma y greater than 0 and x plus y is equal to 1 and 0 elsewhere. So now what will happen is that uh, we can now find f of y. So marginal distribution we need to. So f of y and y. To find the marginal distribution, what we use is that we use the limit of x. Remember, it is limit of x limit, let's say, and then fxy, and it is integrated over dx. So now the limit of x is what, 0 to 1 minus y, right? Fxy is 6 1 minus x minus y dx. So now 1 minus y is constant and x is a variable. So it will be 6 we can take out, and then it will be 1 minus x, sorry, it will be 1 minus y times x plus minus x square upon 2. So its integration will be x square upon 2, and then it will be from 0 to 1 minus 1. So now we can write this as 6 1 minus y whole square minus 1 minus y square divided by 2, right? Which is x, which is so basically f by y will be equal to 3 1 minus y square. Now f by at 2 will be equal to 3 1 minus 1 upon 4, and that will be 3 upon 4. Now what we need to find is that expectation of x given y is equal to 2. So expectation of x given y is equal to 2 will be what? Expectation of x given y is equal to 2 will be 0 to half. Why? Because x plus y is equal to 1, right? So at this point, when y is equal to sorry, when x is equal to 1 minus y, it will be uh, 1, sorry, it was given y at half. So it will be 1 minus 1 by 2, it will be 1 by 2. So x limit will be 0 to 1 by 2, and then in the upper portion we have 6 1 minus x minus y, and in the division we will have this. So it will be integrated over 0 to half, so 0 to half. Now we can write this as 3 uh, 2 minus 1, so 1 minus x divided by 3 upon 4 dx. So this will be equal to 0 to 1 by 2, 3 3 will be cancelled out. 1 by 4 will come as 4, and then 1 minus x dx. So 1 minus 2x. 1 minus 2x. Uh, Here is expectation, so 1x will come here. So it will be x. Now this expectation will be equal to 4, 0 to half x minus 2x square dx. So it will be what? 4. For x it will be x square upon 2. For this it will be 2x cube upon 3, and range will be from 0 to 1 by 2. Okay. So 4 in the time of 1 by 2 it will be 1 by 8 minus 1 by 2 times 8 3. Okay, so this will write it as 4 by 8 1 minus 2 by 3, which will be 1 by 2 in 1 by 3, which will be 1 by 6. So 1 by 6 will be the expectation. We will move to the next question. Next question given here is that x1, x2, x3, x4 are four independent random variables. So four independent random variables means f of x1, x2, x3, x4, x1, x2, x3, x4. So f of these random variable at point x1, x2, x3 up to x4 is equal to uh, this is what this is joint PDF. Now this joint PDF will be equal to fx1 at x1, fx2 at x2, fx3 at x3, and fx4 at x4. Okay. So this is joint PDF and this is marginous marginal PDFs. Okay. So uh, what is this? This is y is equal to this one is according to this line. Now the respective means are one and they all follows the exponential distribution. Now, if you try to remember what happens is that when exponential distribution when xi follows exponential distribution with any parameter lambda, then the expectation or mean of the distribution is 1 upon lambda I. So you have given 1 upon lambda I is equal to uh, let's just say 1 upon lambda 1, 1 upon lambda 2, 1 upon lambda 3, and 1 upon lambda 4 is given as 1, 1 by 2, 1 by 3, 1 by 4. Okay, so basically, what we get from here is that x1 follows exponential 1, x2 follows exponential 2 because lambda 2 will be 2, x3 follows exponential 3, and x4 follows exponential 4. Okay. So we have these 4. Now the question is that then the y is equal to minimum of this has an exponential distribution with mean equal to what? So y is equal to what? Minimum of x1, x2, x3, and x4. So y is what minimum of x1, x2, x3, and x4, and then we want to find its mean. So this is basically what this is the joint PDF. So joint PDF is this. So we need to do is find we do the multiplication. So probability of y greater than or equal to y will be is equal to this product and then p of x y greater than or equal to y. So this is the product that means x1 is greater than y, x2 is greater than y, x3 is greater than y, and x4 is greater than y. Now for the exponential distribution, uh, it is e to the power minus lambda x because what is fx, that is p, y less than equal to y is 1 minus e to the power minus lambda x, right? So, uh, 1 minus fx, that is p y greater than or equal to y, will be what? 1 minus e to the power minus lambda x. So that one we will left with e to the power minus lambda x. So now we know the lambda, and then it will be y. So e to the power minus y for the first one, e to the power minus 2y for the second one, e to the power minus 3y for the third one, and e to the power minus 4y for the fourth one. So this total will be 4, 3, 7, and then 9, and then 10. So it will be e to the power minus 10. Okay. So now, uh, what is the expectation? Expectation is what? 1 upon lambda. So this one is lambda is equal to 10. So expectation of y will be what? 1 upon 10, which is zero point 0.1. So zero point 0.1 will be the answer. Now, uh, this question given here is that test results from an electronic circuit board indicate that the 50% of board failures are caused by the assembly defects. Okay. And 40% are due to the electrical components, 10% are due to mechanical defects. So suppose that 10 boards fail independently, then let the random variable x, y, and z denote the number of assembly electrical mechanical defects. And one more. So firstly, what is given here is that 50%, that means zero point 0.5. Uh, so let's just say failures, okay, happen due to assembly, and this is a defect, this is failure probability. Okay, so this is zero point 0.5, and then due to electrical one, it is zero point 0.4, and mechanical one is zero point 0.1. Okay, so 10 boards fail independently, 10 boards fail. Okay, and then we want to find the probability that 5, so let's just say failure, number of failures, total is 10. So 5 happen due to assembly, 3 happen due to this, and 2 happen due to a mechanical effect. So now what we can do is that we can simply write the formula 10 factorial by 5 factorial by 3 factorial by 2 factorial. Now from where this formula comes, this is very important. So this is what, firstly we have 10 failure rules. Then what we can do is that we can choose 10C5. Out of 5 we can choose 3, and out of 3, so out of 2 we can choose 2 last. So that one will be 10 factorial by 5 factorial, 5 factorial, 5 factorial by 3 factorial, 2 factorial, and then 2 factorial by 2 factorial. So this one will be cancelled out. We will be left with 5 factorial divided by 10 factorial by 5, 3, and 2 factorial. Okay, so this is how we will choose. Now, um, now what is given here is that we want to find its probability. So probability x is equal to 5, y is equal to 3, z is equal to 2 will be what? It will be 10 factorial divided by 5 factorial divided by 3 factorial divided by 2 factorial, and then its multiplication with this probability. So it will be zero point 0.5 to the power 5, zero point 4 to the power 3, and then zero point 2 to the power, right? So now we need to calculate this. So see, 10 factorial divided by 5 factorial will be 5 factorial, which will be 120 divided by now 6 divided by 2, and then multiplication with zero point 0.5 to the power 5, and then again multiplied by zero point 0.4 to the power 3, and then again multiplied with zero point 0.2 whole square, and it will come out as, so this one was point 1. Okay, so now this one will come out as 0.050. So this one will be the answer. So next question given here is that soft drink cans are filled by an automated filling machine. Assume that fill volumes of the can are independent and normal random variable with standard deviation of 15 ml. Now suppose the probability that firstly what we can see here is that normal distribution following, and then standard deviation given here is that 15 ml. Now suppose the probability that mean of sample of 100 cans, okay, so n is equal to 100, is below 350 ml is this. So and then what should be the mean we want to find. So we can take x as the fill volume, right? We can take x as the fill volume, and then x follows normal distribution mu, which we want to find, and then standard deviation is 15 ml, so variance will be 225. Now probability that x is less than 350 is what? It is 0.005. So this is 0.005. Now what we can do is that what we generally do, we will convert it into the standard normal variate. Now to convert it into standard normal variate, it will be x minus mu upon sigma less than 350 minus mu divided by sigma is what? Sigma is 220, sigma is 15. So this probability is 0.005. Now we want to find firstly where is 0.005 lies. Okay. So what we can do is that we can subtract it by 1 minus. Uh, we can do its negative and then we can take the negative again. So 0.005 will be 1 minus 0.005 is 0.995. Now we will see the Z table for that. Z table for normal distribution. Choose. So for minus it is given that 0.005 will be at somewhere here, 0.0051, so it is minus 2.57, right? So it is at minus 2.57, so this is pi at minus 2.57, and this one is what? This one is 5 350 minus mu divided by 50. So pi we can take out, and then it will be 350 minus mu is equal to minus 2.57 times 50. So mu will be what? It will be 350 plus plus 2.57 into 15, and then it will be around 353. Okay. So it was, I think, 1.5. So it will be 2.25, and it will be 1.5. This will be 1.5. Then its multiplication will be something like that. 8, 6, 3, 7. So this will be the answer. Now move to the next question, which is given here is that a plastic casing for a magnetic disc is composed of two halves. The thickness of each half is normally distribution with the mean 2 millimeters and then standard deviation point. So x1 and x2, let's say, are two halves. Are, thickness of two halves. Okay. So x1 and x2 both are following this distribution, normal distribution, 2 mm and then 0.1 square. Given here is that two halves are independent. What is the probability that total thickness exceed 4.3 mm? So total thickness means x1 plus x2. So we can define it as y, which will follow some mu and sigma square. Now to find mu is that it will be expectation of x1 plus x2. Expectation of x1 will be 2. This one will be 2. So it will be 4. And then just say sigma square will be So now we can see here is that so we have this x y z is equal to what? C, and x is square plus y square is less than or equal to 1. So 0 to z. So what we can do is that we can just integrate 4 0 to 1, 0 to root 1 minus square, and then 0 to 4 or constant dz dy dx, and that sum will be equal to 1. Sorry. Let me just add some pages here. So we can do the integration as 4 0 to 1 and 0 to root 1 minus x square. And then for c is constant, so we can take it out. And then dz will be z. One time of this will be 4 again. It will be dy dx is equal to 1. Then we will have 16c is 0 to 1. And then y. So for y, it will be 1 minus x square, and at the point of 0, it will be 0. Dx is equal to 1. So ultimately, this will be 16c. And for this, the formula is what? X 1 minus x square divided by 2. And then plus this one will be a square here is 4. So it will be half sine inverse x, and that one is 0 to 1. So this one is equal to 1. So this one is 16c. Now in the time of 0, it will be 0. In the time of 1, it will be 0. This is sine inverse x. Sine inverse 1 is pi by 2. Right? Sine inverse 1 is pi by 2. And this is pi by 4. And 1 by 2 is outside. So that one will be pi by 4 will be total. Pi by 2 into 1 by 2. So it will be 1 by 4. So C we will have as 1 upon 4 pi. So now we can say that the f function defined here x, y, z is 1 upon 4 pi, and the region for this is 0 to z4, and then 0 to x squared plus y squared is less than or equal to 1. So x squared plus y squared is less than or equal to 1, 0 to z4. Now we want to define the marginal probability function of x. To find the marginal probability function of x, what we will do is that we will integrate over z and y. So this one is for z, and we have taken multiple of 2. Why? Because the region, this one is that either we can do minus 1 by x to root 1 by x squared, or either we can just take 2 times. And then it will be 0 to 4, 1 upon 4 pi, which is c, which is f, and then it will be dz by. So for dz, it will be just 4 upon pi. So it will come out as 2 upon pi, 0 to root 1 minus x square, 1 dy. So it will be what? 2 upon pi. Now that is same as we did before. It will be x by 2, 1 minus x square is 1 upon 2 sine inverse x And that one will be 0 to 1. So in the time of 1 and 0, it will be 0. In the time of 1, it will be I by 2. So, sorry, 0 to 1 minus x. That is, so this is dy, so it will be just 2 upon I root 1 minus x square. We don't need to further use 1 for that. So fx will be 2 upon pi minus x square, and x ranges from minus 1 to 1. Now the next question is that x and y be the continuous random variable with joint PDF. And then we have given fxy is equal to this e to the power minus y, 1 minus e to the power minus x. And then at this. So we need to find expectation of x plus y. Now, expectation of x plus y, we can do it either in two forms. Firstly, if we can take, we will take this 0 to infinity, 0 to y. That means we are doing the integration firstly for x. Or we can do is that x to infinity, that means we take do the integration x to infinity. Here we will take dx dy. Here we will take dy dx. Okay. And then for the next one, this will be the 0 to infinity. So we are doing in this way. You can do it in other way also. 1 minus e to the power minus x into, of course, x plus y. And we want to find the expectation, and then it will be 0 to infinity. And here we will do in the different way. This is e to the power x, e to the power minus x, 1 minus e to the power minus y, x plus y, and then here it will be dy dx. Now you can see is that in first and second there is just changement of variable x and y. So we are just putting y in place of x and x in place of y, nothing else. So if we do the integration of first one, then it will be equal to the integration of second one also. So we will just make it for the first one, and then we will just do it as 2 times, and then that will be the answer. So for the first one, we will do the integration. We add some pages. Black ones. So it's this. So this one we have. Now what we will do is that we do the integration of first one and multiply by 2. So for the first one integration, it will be 0 to infinity, 0 to y, x to the power, x into e to the power minus y, y into e to the power minus y, 1 minus e to the power minus, right, dx dy. We are just opening these brackets. So that one is x e to the power minus y plus y e to the power minus y minus x e to the power minus x e to the power minus y minus y e to the power minus y e to the power minus x, and then dx dy. So for the first term, this one is constant, this one is total constant, this one is constant, and this one is constant for x, right? So now in the time of integration, this one will be what? X square upon 2 e to the power minus y plus this will be x y e to the power minus y minus x e to the power minus x from 0 to y. So that one will be x e to the power minus x is minus x e to the power minus x minus e to the power minus x and then plus, sorry, minus y e to the power minus y and then e to the power minus x will be will come as plus. It will be from 0 to y and here dy. So it will be 0 to infinity. If you put 0 here, it will be 0 and otherwise it will be y square upon 2 e to the power minus y plus y square e to the power minus y minus y e to the power minus y to the power y minus and then minus e to the power minus y 1 minus y e to the power minus y. So e to the power minus y, you can check that on your own. And then it will be, its integration will be what? Now firstly we will write it as 1 term. So it will be 3y is upon e2 minus y, this one and this one. Then y e to the power minus y e to the power minus y, that one will cancel out. So y e to the power minus 2y minus plus y to the power minus 5 minus e to the power minus 5 plus y e to the power minus 2y and then plus e to the power minus 2y dy. So this and this will cancel out. So we will left with these equations. Now it will be 0 to infinity. So 3y square upon 2 e to the power minus y will be what? Y to the power 2 minus 1. So gamma 2 by 2. Sorry. And it will be 3 by 2. That gamma will be 1 plus y e to the power minus y will be y to the power 2 minus 1 gamma gamma and then here it was gamma 2 so it is 2 minus 1 then that one will be 1 next e to the power minus y will be 1 upon this it will be minus 1 for the last one e to the power minus 2y will so this one will be cancelled out will be 3 by 2 plus 1 by 2 2 so expectation of x plus y will be nothing but 2 times 2. Next question here is that the x1, x2 up to x10 are IID random variable following an exponential distribution with mean 9, and then we want to find this probability of y greater than 7 and given y less than, so y greater than 7 given y greater than 4, and this x to x10 are ID, that means independent, and all have mean this. So this we can write probability of y greater than 5 is, uh, as we have done earlier, probability of xi greater than y, and then it will be e to the power minus 10 by divided by 9, as 9 is the mean, right? So that one will be a probability of e to the power minus 10 by 9. So probability of y greater than 7 given y greater than 4 will be is equal to, and it will be e to the power minus 3 10 upon 9, because 3 will be the y, and then it will be e to the power minus 3.33, and that one will be 0.0357. So this one will be the answer. Now the next question we have here is that, uh, so this is x3 and this. Now we need to understand that what is this? This is the minimum. X3 is generally the minimum. So f of y r or y3, whatsoever you say, is n factorial by r minus 1 factorial into n minus r factorial, and then it is y r r minus 1 1 minus y r, and then it is n minus r, right? So here n is 1 5 variables are there, and at 3 we want to find, so it is 5 factorial by 3 minus 1 2 factorial, and minus r will be 2 factorial by 3 2 square, and then 1 minus y 3, and minus r will be 2. So this is a. So a is 5 factorial divided by 2 factorial, 2 factorial. So which one will be 120 divided by 4, which is 30. A will be 30, and then B is 2 and C is 2. So it will be 32. Now the next question is that we want to find the variance of U. So to find the variance, what we do is that we just find its expectation of u square minus expectation of u whole square, right? So expectation of u square is what? Expectation of u square is uh, firstly we find expectation of u. Expectation of u, that means expectation of xy will be equal to 0 to 1, 0 to 1 xy times x plus y dx dy, right? So so 0 to 1 uh, 0 to 1 xy x square y plus xy square and then dx dy. So this one is x square y plus xy square dx dy, and then we can do firstly with dx or dy, doesn't matter. So let's just see, we are doing with respect to dx, so it will be 0 to 1, and then for with respect to x it will be x cube upon 3y plus y square x square upon 2, 0 to 1 dy. What remain? So it will be 0 to 1 y upon 3 plus y square upon 2 dy. So it will be what? Y square upon 6 plus y cube upon 6, 0 to 1. So it will be 1 by 6, 1 by 6, 1 by 3. Right? Now the next is expectation of xy square. So that one will be 0 to 1, 0 to 1, and then x plus 1, x square, y square, x plus y dx dy. So it will be 0 to 1, 0 to 1 x cube y square plus x square y cube dx dy. So it will be 0 to 1. X cube will be x to the power 4 upon 4, and then this one will be 3 dy. So it will be y to the power 4 of this one. Y cube with y square 4 by 3, 3 by 4. So basically 1 by 12. So it will be 1 by 6. So now the variance of u will be equal to 1 by 6 minus 1 by 3 square, which is 9. So now we can take it as 18, and then it will be 3 minus 1 by 20. So this one is this. Now this is minus 2 e to the power minus xy, and then we want to find x plus y. Expectation of u. So expectation of x plus y will be equal to 0 to infinity, 0 to infinity, x plus y, 2 e to the power minus x, e to the power minus 2y, and then dy dx. So 2 will come out, it's a constant, it is 0 to infinity, and then 0 to infinity. We can firstly just multiply e to this e to the power minus 2y, and then plus y e to the power minus x e to the power minus 2y dy, and then dx, right? So that one will be 2, 0 to infinity, and then we can integrate it. So 2, 0 to infinity, it will be x e to the power minus 2x, and then for e to the power minus 2y it will be 1 upon 2, and then e to the power minus x, what we can do is that e to the power minus 2y we can take it as t, 2y as t, and then we can solve it. So ultimately we will have 1 by 4 dx. So it will be 2, 0 to infinity, x to the power minus 2x by 2 plus e to the power minus x upon 4 dx. Now for this, it will be, if you do the integration, it will be 1 by 2 will come out. So x to the power minus 1 by x is what? Gamma 1. And e to the power minus x, if you put infinity, it will be 0. In time of 0, it is 1. So it is 1 by 4. So ultimately, we will have 3 by 4 into 2, which will be 3 by, so 3 by 2 will be the x. Now, next question you can say is that x and y are independent continuous random variable with respective densities, which is given here in this form, that fx and f right. So in this form it is given fx is equal to 1 upon pi root 1 minus x square, and then f of y is equal to 2y e to the power minus y square. So these are independent. To find the expectation of x plus y, what we can do is that we can just uh, write it in the separate form. So we can write it as minus 1 to 1 x 1 upon pi root 1 minus x square dx, and then 0 to infinity 2y e to the power minus y square y dv. Now, either you can just do the whole process to solve this, like firstly do the integration of this and do the integration of this. You can do this whole process, or you can just simply understand that this given here is an odd function. So what is odd function? It is odd function is f of x is equal to minus of f of minus x. So if you put minus here, so it will be minus x and this will be positive. So f, this one, take it as f, right? So f of uh, x is equal to f of minus x, and when this condition happen, minus a to a fx dx is equal to 0. So when this term is 0, it doesn't matter what's the value of this term, the whole integration will be 0. So this will be the solution. Now the next question here is that x1, x2, x3 up to x4 are independently identically distributed random variables with density this, right? And yi is equal to minus log of xy, minus log of xi. Minus log of xi. So what I can do here is that yi is equal to minus log xi, and we want to find the expectation of yi bar. To find this expectation of yi bar, what we can do is that we can expectation of yi bar will be equal to what? It will be equal to expectation of yi summation divided by 4 will be 1 by 4 expectation of summation yi. Now for each yi, because y1 is minus log x1 and each of xi are following the same distribution, so uh, each of yi will also follow the same distribution. So when these are same distribution, its mean will also be the same, because same distribution, same parameters. So it will be summation I will come out 1 upon 4 expectation of yi, right? So this will be 4 times 4, so it will simply be equal to expectation of y, right? Now now we can do, what we can do is that we can find the expectation of yi. So expectation of yi is equal to minus log xi. So we can just do it in terms of minus log x, and then we can put the value of fx. So it will be minus log xi, and then fxi is 1 dx. So for this it is what? X log x, the integration of log x is x log x minus x 0 to 1. So that one will be minus, in term of 1, log 0 will, log 1 is 0, in terms of 0 it will be 0. So we will left with only minus 1, so it will be 1. So expectation of y bar is equal to expectation of yi, so it is 1. Moving into the last question, you need to have some idea of theory. Okay, so 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 theory is needed here, because we are dealing with the u is equal to y upon x plus y. So we are dealing with the transformation, what we call as transformation. So in case you have gone through these lectures, which would not, then what is the thing is that we have, let's say we have x I b continuous random variables. Okay, xi be continuous random variable with the joint EDF fx. Okay, so uh, what we do is that, let's say here it is given u is equal to x plus y divided by x plus y. So what we will do here, we will simply take uh, v sorry, v is equal to x plus y, and then y is equal to uv. So x is equal to v minus uv, which will be v 1 minus u. So now, sorry, x. Right? Now, as you can see, what we did here is that we have simply we have converted x and y in terms of different variables, and then we will convert this fxy also. This fxy is what? This is exponential distribution lambda. So fxx is 1. X and y both are independent random variable. X and y both are independent random variable and both follows exponential lambda, right? So it will be e to the power minus x1 plus x2 lambda, and then for similar for the next one also, right? So f fx x is equal to, or is equal to f by y will be equal to lambda e to the power minus lambda, uh, sorry, for fx it will be lambda x, and then for fy it will be lambda e to the power minus lambda y. So what will be, and then these are independent, so fxy will be equal to what? It will be lambda square e to the power minus lambda x plus y, right? Now x plus y is what? 3. So in, if this we have, so we have given here fxx. So then we can do is that we can define the functions x i's in terms of some ui's, like f of ui, better say, right? So we can do this function, we can do this transformation, and then we find the del xy del uj. Okay, and then the next, so the Jacobian given here is that del of x1 divided by del u1 up to del of x1 divided by del u n. Okay, and then this goes, and then this one is del of xn divided by del of un, and del of xn x1 xn divided by del of un. So this is the Jacobian, and then we find f of u at u is equal to f of x at x I whatsoever was the multiplication. I'm sorry, at u, and then multiply with Jacobi. So this what is given here is that exponential. So f of xy will be lambda square e to the power minus x plus y lambda. So now Jacobian we can write u is equal to y upon v, uv is equal to y, and then x is equal to sorry, x plus y is equal to v. So x is equal to v 1 minus u, right? So to find the Jacobian, what we will do is that v 1 minus u, right? So x1 is that v 1 minus u. Uh, so for this u it will be v, and then for this v it will be u, and then this one is 1 9 sorry u, and then this one is minus this one is uv. So so ultimately the thing we will have will be so there is some mistake. I think we will do it in the next page. So Jacobian we want to find. So y is equal to uv, and then x is equal to v 1 minus u, right? So when we will do with y, so u this will be v, and then for this it will be u. Again with y it will be 1 minus u, and then sorry, it will be minus v, and it will be 1 minus u, right? So minus v minus 1 minus u, and then plus uv. So it will be minus v plus vu plus u. So that one will be minus v. So we will left with just minus 1. So this one will be the Jacobian. So now f of u, and then we take always the mod of Jacobian. So it will be e to the power minus, and then that was v lambda n times v and then it was xi greater than 0, v greater than 0. So now to find f of, firstly we need to find f of u, u comma v. So to find the f of u, we will simply do the integration over this v part. So it will be e to the power minus lambda v dv, and that one will be equal to 1. So, v e to the power minus lambda v. So what is this? That one will be gamma v. So gamma 1, that one will be 1. And then expectation of u square will be what? 0 to 1, because here v follows this and u will be in between 0 to 1. Why? U is x divided by x plus y. So its limit is 0 to infinity, its limit is 0 to infinity, then x u will be in between 0 to 1. So it will be 0 to 1, and then u square du. So it will be u cube by 3, 0 to 1. So that will be 1 upon 3. So 1 upon 3 will be the. So this is all from today's class, and thank you everyone. And in this video, there are so many stoppages because my laptop hanged on, and it was happening again and again. I don't know why, but I will surely work on that. So thank you for joining. Is still relax, and if it happens in case of video that it is just not working, then I apologize for that, and then just go for the video. Okay, thank you.